The landing gear performed flawlessly during the cycle test. All green. Confirmed. The data aligns perfectly with the stability model.
Voice. A civilian aircraft does not need sharp turns, sudden direction changes, or abrupt acceleration, because its mission.
On the matte gray metallic surface, light reflects in soft streaks, reminding that every curve of the aircraft. The smoothness here is critical for the load range.
Agreed. The structural integrity is flawless.
Look at this reading. The stability makes monitoring significantly easier. It definitely streamlines the detection process. The male engineer, aged 25 to 30, places his hand near the wing edge, where the white light highlights every seam, clearly seen.
That stability creates a major question in the quiet hangar. If civilian aircraft are already difficult to maintain, why are combat aircraft even harder?
Check the pressure readings for panel 7. The sensor data looks slightly off compared to the baseline.
There's a slight ripple in the coating right here.
Confirmed. Reading within tolerance, logging it now.
Civilian aircraft are designed to operate under predictable schedules, so maintenance relies heavily on data and repeated inspection routines.
The female engineer inspects the wing area with a slow rhythm, understanding that stability in civilian aircraft does not allow carelessness.
The workers aged 22 to 25 observe each action, realizing that what makes civilian aircraft reliable is not simply. See the fatigue pattern on the tablet. It matches the expected propagation.
Yes, we need to document this seam thoroughly.
The male engineer, aged 25 to 30, understands that civilian aircraft are easier to maintain not because they are less important, but because their design allows more predictable states.
This foundation becomes the first benchmark, because to understand why combat aircraft are harder to maintain, one must first understand how civilian aircraft are protected by stability.
What would happen if a system did not exist within such stability?
If an aircraft must constantly perform sharp turns, strong acceleration, and endure changing loads under high pressure,
we have a major instability warning.
Look at the curvature. Altitude is dropping faster than projected.
The components here are definitely pushed beyond stable limits.
Agreed. We have to ground it for deeper inspection.
The new robotic arm seems much faster. Yes, but we need to monitor the pressure levels closely.
Civilian aircraft must avoid surprises, while combat aircraft exist within them, explaining why maintenance processes cannot be the same.
What must be sacrificed when stability is replaced with extreme flexibility? Look at the microfracturing right here.
The telemetry data confirms significant stress concentration at this joint.
That last bank generated a massive spike right here. We need to cross-reference the air density. Already on it. The reflection data shows the skin held up fine.
The male engineer, aged 25 to 30, sees that each sharp maneuver introduces additional load on the frame, wings, and structural joints.
The female engineer watches the flight path, where the aircraft constantly shifts direction, forcing systems into unpredictable stress cycles.
A combat aircraft is harder to maintain because it must react, maneuver, and endure extreme forces while sustaining high flexibility under pressure.
The hangar remains clean and quiet, but the light on the male engineer, aged 25 to 30, grows harsher as he
The female engineer understands that the same qualities that make combat aircraft powerful also make every component require deeper inspection after each mission.
The workers aged 22 to 25 imagine components enduring vibration, heat, torsion, and shifting loads, realizing maintenance cannot follow simple repetitive patterns.
Combat aircraft are built for flexibility, but that flexibility means fewer repeated states and more unpredictable signs after each operation.
Andres. As the combat aircraft disappears from the screen, the answer becomes clear. It is harder to maintain, not because it is inferior, but because
The stress factors on the combat model are peaking during the dive maneuver.
Yet the civilian data remains completely stable at high altitude.
Civilian aircraft need that stability for predictable limits.
Right. But the flexibility for combat is a completely different design challenge.
Maintenance of civilian aircraft follows consistent patterns, while maintenance of combat aircraft require interpreting the traces of extreme stress.
Stable surfaces reveal predictable inspection points, while stressed surfaces from aggressive motion reveal complex hidden fatigue. Each combat mission leaves a unique pattern because rapid movement and variable loads challenge components differently. One design minimizes variation, while the other accepts variation for performance. The civilian work is so standardized, just repetition. Exactly. But with the combat aircraft, we deal with far more variables and uncertainty.
This wear mark seems stable, but considering the extreme conditions it was under, it's critical.
Understood. The context changes the classification entirely.
The difference lies not in importance, but in the nature of stress each aircraft endures.
The question of why combat aircraft are harder to maintain becomes a question about the technical cost of flexibility.
Look at that finish. It's clearly the result of their long-term stability design. The female engineer aged 22 to 25 understands that the flexibility of combat aircraft is the result of accepting high-pressure conditions.
Rerunning the scan on the port manifold, are the readings stabilizing now? Yes, the thermal signature is consistent across the array. Good catch. We'll sign off on this section.
Combat aircraft are harder to maintain because they endure more variation, more load changes, and more unpredictable operational states.
Civilian aircraft are not simple, but their stability allows consistent data and repeatable inspection cycles.
This deformation suggests excessive stress concentration.
The telemetry data flagged this exact spot after the last run. It's holding, but barely. We need to cross-reference the sensor logs with the full stress history.
Understood. We'll prioritize the fuselage mounts.
The civilian aircraft stands as a symbol of stable trust, while the motion of combat aircraft echoes as a symbol of costly flexibility. There is no absolutely correct design because each aircraft is loyal to its mission. And when that is understood, it becomes clear that combat aircraft are harder to maintain, not because they are inferior, but because they follow